So we got our cube root graphed, and everybody's okay with how we're transforming the points? We understand how to get there? Okay, so then filling in the rest of this should be a piece of cake. So the domain is the same as the parent function. I'm going from negative infinity to infinity. Range is also from negative infinity to infinity. Not that I can see. Will I eventually have one though? Yes. So even though I can't, I'll be careful. Most likely, either I do or I don't, and you have to know that you're going to, right? So since we know that our range goes to negative infinity, that tells me for sure it's going to hit it. Does that make sense? So I'll make sure that you know how to know for sure. So I've got to find that. Am I going to have a Y-intercept? Yes. Do you know exactly what that is? Like you have a pretty good idea, but that's not good enough. So we've got to go find both, right? So how do I find an X-intercept algebraically? My X-intercept happens when what? When y is 0. Good. So I substitute y is 0. So sometimes you have to say that to yourself so you do the right thing. X-axis to my y value is 0. F of x is my y. So I'm going to put in 0 for y. That's equal to the cube root of 2 times x plus 1 plus 4. Okay. So some of you aren't very comfortable or have a lot of experience with roots, but don't let it freak you out. It's not nearly as complicated as it looks. I'm trying to solve for x. Don't start trying to do weird stuff just because it's got a cube root in it. You've got to get this term by itself. So we're going to move 4 over here. So negative 4 is equal to the cube root of 2 times x plus 1. Right? So now that I have negative 4 equal to this root, to get x out of it, I've got to take care of the root. So cube root. What's the opposite of that? Cube it. So I'm going to cube both sides, right? So I can cube both sides. You can write that in if you need to. And then, so I need negative 4 cubed. First of all, will this be a positive or a negative number? Negative, since it's a cube. So then I got to cube it. 4 times 4 is 16. Then I have to do 16 times 4. Remember, when you multiply by 4, you can double it and double it again. So what's 16 times 2? 32. And then 32 times 2 is 64. Okay, so 64 is equal to 2 times x plus 1. Now, I can distribute in that 2, but do I have to? I do not have to. I can go ahead and divide right here, right? I can divide both sides by 2. So that leaves me with a negative 32 equals x plus 1. So then what does x equal? Negative 33. Careful with the signs there, with actually subtracting the 1 and so forth. So my x is negative 33. But in the blank, I have to write an ordered pair. My x value is negative 33, 0. I got to find the y-intercept. So algebraically, how do I find a y-intercept? Okay, plug in x. What do you mean by plug in x? Plug what in? No. Let me ask you this. Yeah. Well, if I substitute in negative 33 for x, what am I going to get? Hopefully 0, right? Right. So if you did that, like if you thought that's what you were supposed to do, and you put that in there, you're going to get 0, and you're like, what the heck? It's actually a good thing. It means you were right about getting that one, right? But just like for the x-intercept, the x-intercept is the x value when y is 0. So the y-intercept is the y value when x is 0. So we want to do f of 0. So that's to the cube root of 2 times 0 plus 1, and then plus 4 out here. Do not let things like this get you all flustered, right? Because 0 plus 1 is 1 times 2, which is 2. So this becomes the cube root of 2 plus 4. Can I do anything with that? I can't. And so that number has 2 terms. It is what it is, right? I don't care what the decimal is. So my y-intercept is 0, and then cube root of 2 plus 4. You could write 4 plus cube root of 2. It doesn't matter. But if you're going to write the roots first, be very careful not to be sloppy with that and let it hang over and not be able to tell what's underneath, okay? Because that's a big concern. Everybody good with me so far? All right, so our extrema. Do I have any extrema or critical points? Yes. I have a what? Point of inflection. Good. And what is that ordered pair? negative 1, 4. Very good. And that is a point of inflection. Right, so am I increasing anywhere? Yes, the whole thing. So I'm going to go from negative infinity to infinity. So am I decreasing anywhere? Not if I'm increasing everywhere, right? So then my end behavior, as x approaches infinity, f of x approaches what? Infinity. And as x approaches negative infinity, f of x approaches negative infinity. Good. Good. Miss Williams too. With you. So what is this function called? Reciprocal. So this reciprocal looks like this. So our transformations, and this one has special cases with the transformations, right? I can leave this negative, so that negative tells me for sure I'm going to reflect somewhere. So I'm going to reflect in what do you think? Okay, is there really a wrong answer right here? No, because it really could be either one. Now, technically, if you're the way we do everything, it's in which means reflect in the y-axis, but if you did x-axis, that would be fine. You don't do both, right? I can't reflect in x and y, or it's just there's too much going on. But if you put x, I wouldn't count it wrong, and you wouldn't get the wrong graph in the end. You'd be fine. All right, so then I've got to look at this 4. Now, being in there, yes, it's part of the fraction, so we could tie it to x, but I really think that when it's in the numerator, I think that it will make more sense to y'all if you look at it split up. And by that I mean this. This is the same thing as saying 4 times negative 1 over x plus 3. Would you agree with that? Thing? Okay, so then now this is out front and it's representing your A, right? It's outside, so would that be a vertical or a horizontal something? Ooh, if it's outside, if it's not in here, it's outside, so that would make it vertical, right? So this is going to be vertical. And then you could force it into horizontal. I'm going to show you what that would look like. I don't think most of you would think of it like that. I wouldn't necessarily think of it. That wouldn't be the first thing I would try to do. But this is also could be written as negative 1 over 1/4 times x plus 3. That has the same value. So if I did that, now it's inside the fraction, right? And so it's being multiplied by x, which means it's horizontal. You take the reciprocal, and it also could be thought of as a horizontal stretch by a factor of 4. Does that make sense? So either one of them would be right. And it's important for you to know that they both work, because that's how we're going to use our points with these, and that's going to be important for us. So we're going to put a little star here because we kind of use this in a special way for reciprocals. And we got 3, tell me is happening. Translate. Left 3, good. And we're going to put a little star here too. Because usually when we go through our transformations, we leave translations to last no matter what. But we actually have to start by looking at it, and then we also end by looking at it. And I'll show you what I mean here. We're going to get our anchor points. We only had 2, right? We had these 2 anchor points, and that's all we had because we also have asymptotes, right? And those will help us too. So my anchor points are 1, 1, and negative 1, negative 1. I'm not going to draw in my original asymptotes because I think that makes it too confusing. You know they're on the axes. It's not like they're fancy and weird anyway. So to get my asymptotes drawn on there first, that's why I have to look at the translation, because your reflections and your stretches and compressions do not affect your asymptotes. They just hang out there while all that stuff's happening. But the translations do. If this is going to get translated to the left 3, then this asymptote that's here on the y-axis also gets translated to the left 3. So it's now at x equals negative 3. Need it on the board again. Particle transformation at all, so translation. So this stays on the x-axis. Everybody okay with how we got that stuff for our asymptotes? Ask me a question if you got one. All right, so now we're going to transform these points. Okay, and remember, your reciprocal is a special case because we can look at this 2 different ways, and we're going to look at it 2 different ways. I'm going to start with this point right here. I'm going to reflect it in the y-axis, so it ends up right here. I'm going to have a vertical stretch by a factor of 4. So what gets multiplied by 4? The y. So my y value is 1. When I multiply it by 4, it ends up being 4. But my x value stays the same, right? Same x value, y value is 4. Then I have to translate it to the left 3. 1, 2, 3. And my point ends up right there. Everybody okay with that? Now, for reciprocals and reciprocals only, we go back to that original point again. And then we're going to go through this again. This time, we're going to do a horizontal stretch, since it could be either one. So I'm going to reflect it in the y-axis. I end up here. Horizontal stretch means I'm multiplying x by 4. So my x value is negative 1. My new x value is negative 4. And then I translate left 3. 1, 2, 3. And I end up there. And so I get 2 points in that one section of the graph, and that's helpful for me to get my shape. Otherwise, that 1 point doesn't really help me. Notice that I did not take this point and do the vertical stretch and the horizontal stretch at the same time. I did it once with the vertical stretch, once with the horizontal stretch, okay? And then I can draw that in right there. So that's how your one anchor point produces. So I'm starting with, I reflect in the y-axis, I end up here. Vertical stretch by a factor of 4. My y value is negative 1. It becomes negative 4. Then I translate to the left 3, and I end up right there. Ask me a question if you got it. Don't just lie to me and tell me you totally understand if you're lost, because then that's on you. Okay. All right, so then I'm here. I'm going to do it again, but this time I'm doing horizontal. So I'm here. I still reflect in the y-axis. I have a horizontal stretch of 4. So my x value is 1. It becomes 4 now. And then I need to translate left 3. 1, 2, 3. And I end up right there. And then there's the other part of my graph. Okay? Ask me a question if you got one. Okay, we understand where the points are coming from? Okay. All right, so then let's go look at our domain and range. My domain is going to start way out there at negative infinity. Does it go from negative infinity to positive infinity? Nope, it goes from negative infinity to where? Negative 3, very good. Then what? Union, and then negative 3 to infinity, right? Because I got that asymptote there that breaks it up for me. So range, I'm going to go from negative infinity to where? 0, good. And then that's a union with 0 to infinity. Okay. Everybody good? Do I have any X-intercepts? No, it does not cross the x-axis because that's where my asymptote is, so I have none. Do I have any Y-intercepts? Yes. Do I know exactly where it is? No, I do not. So I got to find it. To find the Y-intercept, I substitute what? X. 0 for x. Okay, so I need to find f of 0. That's going to equal negative 4 over 0 plus 3. So what does that give me? Negative 4 over 3. So I substituted in 0 for x. Negative 4/3 is what I got for y. When you're writing the ordered pairs, say that to yourself again so you don't put the 0 in the wrong spot. Because I think you know the difference in where the 0 is supposed to go, but that's the kind of silly mistake that happens sometimes just because we're not perfect, right? All right, do we have any extrema? Any max, mins, or points of inflection? No, so we have none. Am I increasing anywhere? Yes, so I'm increasing from negative infinity to negative 3. Then what? Am I increasing any more? Good, from negative 3 to infinity. And then I put a union here, right? Remember I told you that we didn't, and then I came back and I fixed that, and now we're probably confused, and I'm sorry, but there was miscommunication on what we were asking when I was asking if we actually use it here. Basically, anytime you have an interval, you're going to use the unions to connect them. If you have a bunch of ordered pairs listed, like if I have 3 X-intercepts, I don't put unions there because it doesn't make any sense with points. It only makes sense with the intervals. All right, so if I'm increasing for pretty much all of it, then I'm not decreasing. My end behavior as x approaches infinity, what does f of x approach? 0, good. And as x approaches negative infinity, f of x approaches 0. All right, do we have any questions at this point? Yes, I'm sorry, yes.
So what if there's a square root in the numerator?
Like a number or a variable?
A variable.
Okay, so if I have the square root of x over x plus 3, then this wouldn't be a straight up.
Well, not x plus 3, but like say there's a number down there. But like it's like honestly an unrelated question. But,
No, it's okay.
But like I just want to figure out how to do it.
Okay, so like if I had, so are you asking me if I had something like f of x equals the square root of x over 3? Something like that? Okay. So if I have something like this, is this a reciprocal function? No, it's a reciprocal function only if x is in the denominator, right? This isn't even a rational function. It just happens to be a function that's in a fraction. So I think so that this doesn't confuse you and make you think it's like these, because I can see why you're thinking that. This is why you have to have at least some basic fraction knowledge. If you rewrite this, I can rewrite this as 1/3 times the square root of x. Isn't that the same thing? Because if I put that over 1 and multiplied it back, I get the same thing. So if you're looking at it this way, you're less likely to do something weird than if you have this and you feel like it's not making any sense to you. Now, this 1/3, what would it represent? That's think of it as an A when it's down here, right? So when you can split it up like that and actually have them being multiplied instead of having any division, you can help it make more sense to you. Does that help? That's a good question. Anything else? How did I get 2 points? Because I started back over, because I did 2 different things. I started here, I did exactly what we put here. And then I started back at that same point, but this time I did horizontal instead of vertical, because it could be either one. You're allowed to do that for reciprocals only. Don't try and go do that with all the rest of them. It's reciprocals only, reciprocals only. And really that's just kind of a way for you to get another point. If I used every single point and all I did was vertical stretch the whole time, I'd still get the whole graph. And you could sit there and you could do horizontal stretch and get every single point on there. And then we'd have the same graph in the end. It's just kind of a way for you to get 2 points on there to be able to graph it. Okay? But the nature of this, it doesn't matter which way you talk about stretching, it ends up looking the same in the end. Good questions. Anything else? All right. So we're going to flip over on the back and we're going to do number 8. Do you want to do number 8 with them? Oh, the other page. I'm sorry. Yes, on the other page. We're going to go to 8. Do you want to do it? Okay. I don't know if you did or not. I'm going to turn this over to Miss Williams.
Okay. So we're going to start with number 8. Does anyone know what kind of a function this is? Reciprocal. Perfect. So the f of x is going to equal 1 over x. And that parent function is going to look like this, right? So for our transformations, we know that we're going to have This is going to be a horizontal compression. By a factor of 1/2. Does everyone see how I got that? The 1/2? Yes? Okay. And then we know that it is going to have a translation. It's going to be down 1, right? All right, so we're going to plot our anchor points real quick. They're going to be right here and right here. So normally we wouldn't worry about this translation immediately, but it's going to affect our asymptotes, so we need to look at it, right? So because we're translating it 1 down, what do you think that's going to do to the asymptotes? So it's going to move this one down 1, right? Does it do anything to this asymptote? No, perfect. All right, so now we can work on our horizontal compressions of our points. So if we start with this point, it's at 1, 1, and if we're horizontally compressing it by 1/2, are we going to multiply the x or the y value by 1/2? The x. So if we multiply, this would make the x value 1/2, which would bring it right here, right? And then we have to move it down 1. So we can plot that point right here on that x-axis, right? So then to get another point to see where this line is going to look like, or this function graph, we can do the vertical compression like she was just showing us, right? So if we vertically compress this by 1/2, are we going to multiply the x or the y by 1/2? The y. So that'll bring it right here, and then we have to shift it down 1 as well. So it's going to end up right here, right? And then we can graph that, and it's going to be really, really close to those asymptotes the whole entire time. All right, so we've got this half of the graph, so now we need to figure out what's going on down here. So we've got this point now that we're going to horizontally compress by 1/2. So that means we're going to multiply the x by it, and it'll go right here, and then you bring it down 1. So it'll be right here. Yeah. So then we can vertically compress it by 1/2, and it'll come up 1/2, and then you can bring it down to right here. And then you can connect those as well. And they're going to be really close to the asymptote on this side as well, because we know that it's a symmetric kind of function. So now that we have it graphed, we can start studying the domain and all of this information. So for this graph, what's our domain going to be? -infinity to 0, and then what? 0 to infinity. What about their range? -infinity to -1. All right, so do we have any X-intercepts? What is it? Do we know? 1/2 what? 1/2 0, perfect. And we graphed it earlier whenever we did our transformations, so it's this one right here. Do we have any Y-intercepts? No, because there's an asymptote right there, right? So it's never going to touch that Y. Do we have any extremas? No, perfect. Is this graph increasing? None. So then where is it decreasing? What? Union 0 to infinity. Perfect. So then for our end behavior, as x approaches infinity, what is f of x doing? It's approaching Not negative infinity. Negative 1, perfect. Because x is going to the infinity and it's getting closer and closer to this negative 1 asymptote. Does that make sense? So then, as x approaches negative infinity, what is f of x doing? Negative 1 as well. Perfect. All right. Does anyone have any questions about it? Everyone understands? Awesome. Should I pause it?